Hi everybody, so this video is going to be used to show us how to use the quadratic formula. The quadratic formula should always be treated as a last-ditch effort to solve a problem. You should always try to factor first, as factoring to find solutions is far more efficient, and we've seen that through grade 10 and through grade 11. So here I have a quadratic equation, 4x squared plus 6x equals 7. Now, my first step in solving these, regardless of whether I'm factoring or not, is to rearrange it so that way I have it on one side of the equal sign. So I'll create this as 4x squared plus 6x minus 7 equals 0. And so now I can tell that this thing's going to have two roots because its y-intercept is minus 7. So a quick graph of this would have a y-intercept down here. And because this is positive out front, we know that this is going to open up. And actually, I've made a mistake. My vertex is not going to be right there. My vertex is actually going to be the left, but that doesn't really matter at all. All that matters is that we recognize that the solutions are going to be where the graph intersects the x-axis, and there will, in fact, be two of these. So let's go back to just this portion. We'll write it out on a clean piece of paper. So it's 4x squared plus 6x minus 7 equals 0. Now, you would remember from grade 10 that we would call this value A, this value is B, and this value, the y-intercept, as I'd mentioned, is C. And so these are the values of our parameters in standard form, because remember, standard form quadratic is ax squared plus bx plus c is equal to 0. And so that's our standard form quadratic. Now this doesn't factor. I would do my quick check. 4 times 7 is 28. And so I'm looking for the factor pairs of 28 that would get me to 6. And I don't happen to see any of them. And 14 and 2 is only ever going to make 16 or 12, and 11 or 3 or 29 or 27. So it's just simply not going to factor. So I'll go ahead and use my quadratic formula. Recall, it's providing you with x values. And these are the x values of your points of intersection with the x-axis. Now, it provides you with two of them because we have to add and subtract from a particular portion. So that's why there's two values. One of them is the positive value, which will be either to the left or right, depending on signs, and the other one is the negative value. So, oh, geez, that's an awfully awkward vinculum. Draw that a little bit more straight. That's better. So you have negative b plus or minus the square root of b squared minus 4ac all over 2a, and you've got this memorized because, well, you should. So now that we have that down, we can simply substitute in our values of a, b, and c. Now, you've been doing the quadratic formula for some time now. I'm going to tell you just to watch your signs, but I also probably don't show every single step. B squared minus 4ac, I'm just going to leave this as 36 minus 4 times negative 7. I guess I am going to show almost every step. But if you wanted to simplify this or do this portion in your head or off to the side so that you don't have to keep rewriting it, you're welcome to do that, and that's all over 8. So we'll just continue to simplify. Negative 6 plus or minus the square root of 36. Now this is a negative and a negative, so that's going to make it positive. So then we'll have plus 16 times 7. So 16 times 7 is, geez. Really should have done this not in my head. I mean, I could do this in long form here. Or I could recognize that it's going to be pretty close to 16 times 8, which is going to be pretty close to 2 to the power 7. Just do it long form. 42, 112. So 36 and 112 is 148. This is all over 8. Now, this is the correct answer, but it's not necessarily sufficient because we need to have coordinates for these two values. We need to have the x values for these two things. So we'll break that up by doing minus 6 plus this over 8, and minus 6 minus this over 8. Of course, I want to reduce this radical first. So I'm going to go ahead and reduce the radical. I know that it's going to have a 4 that divides evenly into it. So I'll remove that 4 from it. And when I remove a 4, I take the square root of it and it becomes 2. And you can check out my video on reducing radicals for that. So 148 divided by 4 is going to be something along the lines of 9 plus 28, 37. Yeah, I think 37. All over 8. So there's still a little bit of reducing left to do here. I'll have two solutions. One will be x is minus 6 plus 2 root 37 over 8. And the other will be minus 6 minus the square root of 37 over 8. This still isn't good enough, of course. I have to reduce my fractions. So both terms in the numerator are divisible by 2, as is the denominator. So I'll have negative 3 plus root 37 over 4, or negative 3 minus root 37 over 4. And I think you might have noticed my mistake. I forgot the 2 in front, because these two terms should be identical except for the signs. And that's applying the quadratic formula to find the values of these two roots. I hope that you recognize that they are symmetrical. One of them is, and they're symmetrical about negative 3 over 4. So one of them is to the right, and one of them is to the left of that negative 3 over 4 mark.